Okay, welcome everybody. We will start very soon. We'll let a few more minutes for people to enter the webinar. It's great to see you today. Still people arriving. Okay. So I think I will get started. Welcome everyone to the INMS GPNM webinar. We will showcase some new guidance documents and tools for sustainable nitrogen management. So I'm your moderator for today. My name's Bill Bealey. I'm from the UKCEH and also INMS project worker. So we're expecting these outputs to support governments, policymakers and practitioners, scientists and students to understand nitrogen issues. And for the guidance documents today, we're looking at nitrogen budgets, nitrogen impacts, and nitrogen mitigation measures. We will, just to say, throughout the webinar, we will release the URL for the guidance documents online. They are PDFs, reports, so you can then download those. So we'll put them in the chat. And also for questions, we're looking for questions we've got 3 presenters today. So please submit your questions via the chat, or I think you can use also the Q&A tool. And we have a session at the end where we'll be going through some of those questions and getting some replies from the panelists. The session is being recorded, and that will be available on the UNEP website to share with your colleagues. So we hope you find this 90-minute session really useful. And I'm now going to pass on to Mark Sutton. So Mark is the director of the International Nitrogen Management System, which is a GEF UNEP project and process, and he's also co-chair of the GPNM. So Mark, over to you.
Thank you, Bill, and good morning and good evening to everybody. Yes, so for those of you who have not joined a GPNM webinar before, the Global Partnership on Nutrient Management is a multi-actor process looking for better management of nutrients, sustainable nutrient management in the world. The Secretariat is with UNEP, and it's a cooperation between governments, academia, civil society, business, everybody that wants to take part. And if your organization is not yet a member of GPNM, please do sign up to join. So today our focus is on the outputs and guidance from the International Nitrogen Management System. So just to say a little bit firstly about what do we mean by that as a project or a process. That's something that Bill has already mentioned. The first point is to say that the INMS, International Nitrogen Management System, is really a long-term process that goes through multiple projects. The birth of INMS probably goes back to 10 or 15 years now, where we were already working with one regional body, the United Nations Economic Commission for Europe, through their task force on reactive nitrogen. And that was an intergovernmental process supported by expert evidence, but only one part of the world. And the question was, what about the wider world, other regions? Should we not be cooperating on a global level? So that has seen the birth of the International Nitrogen Management System process, which was first funded. We should thank the UK Research and Innovation for the INMS pump priming project, and subsequently funded through the Towards INMS project from the Global Environment Facility through UNEP. Subsequent funding has come again through UK Research and Innovation through its South Asia Nitrogen Hub. Again, one region of the world, but an opportunity to take that process forward. So what do we mean by an international nitrogen management system? Think of a system of science evidence working together, providing support for international policy development, for others to be useful for mobilizing actions on sustainable nitrogen management. So that includes providing fast-track policy support. And we know that from a policy perspective, often the answer needs to be provided very fast. But if you want a fast answer, that means the work has to be done well in advance in order to provide that fast answer. Then there are the slow products, and the products that take many years actually to bring together. And we're going to be reflecting on some of those in the guidance documents that are being presented in this webinar, INMS guidance documents for different aspects of sustainable nitrogen management. One of the things we will not be presenting today is the work of the International Nitrogen Assessment. So the first ever global assessment of nitrogen threats, benefits, solutions, way forward for sustainable nitrogen management. That's currently being finalized for the publishers and will be launched next year. So think there of something like Intergovernmental Panel on Climate Change assessment reports, but now imagine that for the world's nitrogen cycle, all the threats, benefits and opportunities. That's another product that will be coming out of INMS. And together we should think of the web-based tools, which we'll see some of today. So those are the different things. And as I say, think of it as a long-term process supported through multiple projects. When you have questions, what are the things you immediately want to know the answer to? We can often only answer those because of substantial work that's gone on before. Our inputs into supporting the countries with the resolutions on sustainable nitrogen management at UNEA 4, UNEA 5, that distillation has come out of many years of work that's gone before. I think that's the important thing. So that means that when you think about your next questions going forward, what are your questions going to be in 26, 27? We'd like to know now, at least so we can start preparing the way and setting what the agenda will be for the next 5 years. Now, 2025, 5 years until 2030, the Sustainable Development Goals, the Kunming-Montreal Global Biodiversity Framework has the target to at least halve nutrient pollution by 2030. What will be the evidence you want to see going forward in that time frame? So when we come to the discussion and the questions, do give your reactions to what we're presenting today, but do also give your reactions to what you would see as science evidence support for the years going ahead. So with that, thanks very much for joining us. And I think I'm very happy to pass back the mic.
Thanks, Mark. That's excellent. And yeah, please use the chat to put any questions to Mark, any thoughts on what's happening in your country and going forward as well. We'd like to hear from you. So I'd like to now invite Isabel van der Beek, who is from UNEP. She's our project officer for the INMS project. So Isabel, just like to invite you to say a few words on behalf of UNEP and the project, please. Thank you.
Thank you, Bill, but I do not seem to have video. Is it because I joined as a panelist? Okay.
We can hear you, Isabel. That's absolutely fine.
You should be able to have video now.
Is that okay, Isabel?
Video and audio. Apologies.
There you are. Go ahead.
I wasn't registered in the right with the right link. So good morning, good afternoon, good evening, everyone. My name is Isabel van der Beek, and I'm working with UNEP in the Jeff International Waters team. I've been really privileged to accompany the INMS project from its conceptualization to its preparation to its execution, and it's been an incredible journey. The project allowed for us to be fully creative. It's been a targeted research project, especially on the governance front, may I say, at least from my side, defining an income, integrated nitrogen coordination mechanism without income, without money, giving birth to the nitrogen working group hosted by UNEP, being incubators of UNEA resolution, and much, much more. It's always said, however, to come to the end of a project. Your friendships might be on pause for a while until you come with the next best idea. However, to be able to share and showcase a suite of project products and being reassured that through webinar events such as this one and other, many potential users will be exposed to the work of this project and the tools and resources that it has developed. Certainly, at least from my side, is really heartwarming. GEF projects are usually catalysts, and this targeted research project has made revolutionary advances on the art of managing the nitrogen cycle holistically. The tools that will be presented to you today have been developed with the utmost scientific rigor. They've been tested in different geographies, bringing practical hands-on type information and data for the global tools. So please use them. Visit the project websites for more. Reach out to the scientists who gave a lot of their time to make those tools perfect. Share your ideas. This was only a first episode, and we hope to come up with the next generation of projects very soon. Under the Clean and Ocean Integrated Program, which is another initiative funded by the GF, led by FAO in this case, the UK Centre for Ecology and Hydrology, together with UNEP, are helping and supporting the Maldives to put in practice the management of the nitrogen cycle, including looking at innovative technologies, conservation finance with the concept of nitrofinance. So I truly hope that you'll be able to enjoy the presentations, and wanted to conclude by thanking the project team, the experts for all their hard work, as well as the GPNM and NING in particular, to give us the opportunity to broadcast and showcase the work of a modest but very impactful project. Thank you very much. Enjoy and take care.
Thank you, Isabel. It's very kind words, and quite a few of our colleagues, INMS colleagues, are in the audience, and we all thank you for guiding us through INMS over the years. So thanks to you, Isabel. Okay, I think we move on now to our presentation. So I invite Kentaro Hayashi. Kentaro, if you'd like to start sharing your presentation, I'll introduce you. So this is Professor Kentaro Hayashi. He's at the Research Institute for Humanity and Nature in Japan. So he, with other colleagues, have brought together the guidance document on national nitrogen budgets. So you are ready, and I hand over to you, Kentaro. Thank you.
Yes, thank you, Bill, and good evening, good morning, and good afternoon, everyone. As Bill kindly introduced me, my name is Kentaro Hayashi. I'm also responsible for compiling this guidance document together with Wilfried Wainwright, ERS Australia, and other key researchers related to this topic. So I'd like to explain briefly about the guidance document on national nitrogen budgets. So this is the slide. This shows the front page of our guidance document on nitrogen budget, and it's now available through this QR code. Guide you the web link of the INMS project that compile the publications on guidance documents and relevant reports available on website. So I'd like to explain briefly about the table of contents of this guidance document with foreword and the preface. They consist of 6 chapters. One is introduction, and the second is the estimated nitrogen budget for a nation. So I'd like to explain briefly later on using some slides. And the other 3, chapter 3, 4, and 5 provides some ways how to quantify nitrogen budget in a nation. For example, based on the European guidance document that provided a very great annex to concrete, how can I say, calculate the nitrogen budget in a nation, mostly focusing on European countries. And other thing is the model-based approach developed in Chinese colleagues, Virgin Gu. He developed the named chance model, coupled human and natural systems that also estimate the nitrogen flow and the nitrogen budget in a nation. And the last one is an alternative way if one have insufficient data. So using some global scale database or model to estimate nitrogen flow in a target country like this. And today I'd like to also explain some cases of country case studies. And today I'd like to explain briefly about the case of Germany and the case of Japan. And the accompanied to appendices, one is to explain a bit more deeply about the European approach for national nitrogen budgets estimation. And the other is the subsystem considered by the chance model developed by Chinese colleague Virgin Gu. I'll move to the next one. This is maybe I want to take some time to explain here. So what the national nitrogen budget means. So nitrogen budget, we can estimate nitrogen budget, identify and quantify each of nitrogen flows, all of nitrogen flows inside the system. In this case, a system is equal to a nation. So that is why it means national nitrogen budget. So for example, when we speak about the industry sector, there are many flows connected with other pools or other human sectors. And each of flow has of course, its own quantity. We need to identify each flow and quantify each of the flows. And finally, we can estimate, for example, focusing on industry pool, we can identify summing the total input and summing total output. We can identify the budget in this sector, similar to applicable to all the environmental media and all human sectors. Finally, we can get national scale nitrogen budget with the quantitative data for each nitrogen flow. And there are 5 key advantages of a national nitrogen budget. One is visualization. That means raising awareness to potential impacts, for example, air pollution, water pollution, eutrophication, something like that, of very complex nitrogen flows among human sectors and environmental media, atmosphere, and the water body, soil, and coastal zone, something like that. And that's also provided the information, especially for policy people, thinking and providing the intervention points for policy assets to manage the nitrogen status. For example, we should focus on air pollution aspects, or we should focus on water pollution aspects, and so on. And the nitrogen budget also can enable provide information on observation that can be a sort of environmental monitoring and status and effective measures. So effective measures mean that when someone introduces countermeasures against the air pollution, and we calculate the nitrogen budget, so in the next 2 years, we can identify how such measures can make a difference or not. And the nitrogen budget also enables some comparison among countries. Of course, each country has a different size, but when we can using some index, like a per capita nitrogen flow, something like that, it enables comparison between countries in some region and in the world. And the last one is especially important for experts and scientists. The nitrogen budget can identify knowledge gaps, important but less data availability. We can identify this. So, and we can elaborate our study much more to enable the nitrogen budget more precisely. And the next one, this slide shows so already published nitrogen budgets. It's a literature basis. For example, European Union, that is shown on the European Nitrogen Assessment Book. And some countries, mostly in the European countries, Switzerland, Germany, and North America, Canada, Denmark, USA, New Zealand, Estonia, and Latvia, China, Japan, Scotland, Sweden, Australia. Maybe some countries not trying to making some scientific paper regarding the nitrogen budget in that nation. And this is a very simple chart in this guidance document, our guidance document. So how to select an adequate approach to estimate nitrogen budget for a nation. So think about the demand of national nitrogen budget estimation. Of course, yes, in this case. So detailed information required, yes. So in this case, results need to be highly comparable. If yes, we recommend the European approach. That is mostly applicable to European countries. And if not, or if not available for such some nations, so detailed data available. So in this case, chance model can be used. And then if not, then in other cases, so global data sets and global model can provide some information related to nitrogen budgets. That's a very simple schematic view. And I'd like to next explain briefly about each of methodology. First is expert panel on nitrogen budgets. That is under the task force of reactive nitrogen in the European community. So under the long-range transboundary air pollution under the United Nations Economic Commission for Europe. So simply we can say to European guidance of nitrogen budget. So its necessity already shown in the Gothenburg Protocol. Article 7, it denotes the necessity of nitrogen budget estimation. And the guidance document on such an European communities already available through a website. Maybe you can reach later. So cause our presentation will be available later on this webinar, I hope. So you can check it later. So that's provided a really basic concept and the necessity of nitrogen budget. And of course, such an how can I say, article or document need to be underpinned by scientific knowledge. So my colleague Wilfried, now his paper just accepted to environmental research letters. So that's also available through this URL. And this guidance, European guidance document also has an annexes. Annexes mean that a bit small letters, but that consists of now 8 annexes. Each of annex provide the concrete way how to quantify each of nitrogen flow when think about the energy and fuel sector, or think about using this case. So second is material products in industry, and 3 is agriculture, maybe the most important in means of the nitrogen flow. And the 4th is the forest and the semi-natural vegetation. 5 is processing residues. It means that just like a solid waste, such a waste. And the 6th is in this case, human settlements, and it means that of course, human settlements in directly and also including consumption aspects. And the 7 is the atmosphere, 8 is the hydrosphere. In this case, maybe the surface water and the groundwater. We need to think about this. And now this guidance document, European guidance document, not this our INMS document, but the European guidance document annexes that is now applied to some parties in European countries. For example, Austria, Germany, Scotland. Scotland is not a party, but the EU, and Sweden and Switzerland and other European countries now try to using this guidance document annexes to estimate their nitrogen budget in their countries. And second one is chance model. Chance model is the mass balance based and the spreadsheet based model. So that is why easy to use. Using itself is very easy. And that is originally developed by as I mentioned, Baozhen Gu, Zhejiang University and China. And they are now try to elaborate this model to applicable to other countries with adjustments. So similar to GHG inventory guidance, there are 3 tiers. One is tier 1 is still without changing schema parameters, directly use a chance spreadsheet model. Yes, that's easy to use, but you need activity data of target your country if we want to try this. And maybe you see some difficulty when directly use this model because this model is originally tuned for the case of China. So that is why the situation is different among countries. So that's why next one is a tier 2 approach. You may modify some parameters like an emission factors, greenhouse gas or NOx or something like that to better reflect the national processes. And then, for example, yes, treatment efficiencies may be needed. For example, wastewater treatment efficiency or crop production nitrogen use efficiency and so on. And the tier 3 approach is the strongly modified chance model. The case of Japan, I took this approach because the basic nitrogen flows and situations are largely different between the two countries. Because Japan is a highly import-dependent country, so that's why I need to modify this. So that is why I took tier 3 approach. I'd like to explain this very, very briefly later on as a case study of chapter 6. This is a schematic view of chance model. It looks very complex, but please don't think it's so difficult. So this is the national boundary and consists of several, in this case, pools or sectors, and water bodies, atmosphere, and human sector zone. And as I mentioned before, every sector of environment media is connected with the nitrogen flows. So quantify each nitrogen flow, then we can grasp the nitrogen budget in that nation. And the last option for the generic nitrogen budget estimation using available global models and data sets. So need for nitrogen budget, some reveal management gaps and that require extensive data. So if you want to try and estimate your country's nitrogen budget, you need the extensive data. So it's very often difficult for developing countries. So that in this case, global models exist and mostly focus on agriculture. There are many papers and databases available regarding especially agriculture. And for example, focus on crop and livestock systems. And the consensus of key crop nitrogen budget sums, the fertilizer, manure, biological nitrogen fixation, and atmospheric deposition harvest. In some cases, irrigation is also needed. And there are some models provide the livestock budget data or estimated results. But there are some major gaps remain. It means that depending on databases and the models, they provide a bit different results. So that is why we need to collect available data sets and model results and compare them. And they need to, how can I say, estimate the plausible range of the such nitrogen flow of the target country. And there are many challenges to progresses. And there are large uncertainties among global data sets, as I mentioned just before. So that is why benchmark data sets needed to create it. And the FAO and IFA Global Crop Nutrient Budget Database released, and that is updated annually and expanding beyond croplands. And the call to action is to improve the data and the method for all sectors that is needed. And I'd like to explain briefly about some case studies. This graph shows the case of Germany. Germany has a great data set and the good result of nitrogen budget estimation that's provided in the at the benchmark 1995 and the 5-year terms averaged or mean nitrogen budget like an agriculture and traffic means the mobile and airplane and so on, and industry and energy and the last one the wastewater sector. So in the case of Germany, so the nitrogen flow in agriculture is steadily increased, but the nitrogen flows with wastewater is steadily decreased. And that is why total nitrogen loss to the environment is estimated in a declining trend. Next one is the case of Japan. I once estimated this nitrogen budget from 2000 to 2015, but this graph shows the case of the year in 2010. So focus on all human sectors and how the reactive nitrogen lost to each part of the environmental media, in this case, atmosphere, water body, and forest. So when we means also you, got some data on nitrogen budget, we can create such a graphs depending on our necessity. In this case, I wanted to focus on the how much nitrogen flow into Japan outside of the country, and how much reactive nitrogen lost to each of the environmental parts. And now, in the case of Japan, we expand this approach. So now we expand the also, first elucidating or updating our calculation method, and also expanding the coverage of timescale from 1990. Then this is the same as that of GHG inventory. So that's why it's enabled to comparison among the GHG, how can I say, trend of GHG and the trend of nitrogen. We can now compare them. And from 1990 to now 2023 available. And the left-hand side shows total nitrogen input per year in Japan, newly input of nitrogen in human sectors in Japan. And right-hand side shows the reactive nitrogen loss to the environment. So below which shows the atmospheric emissions, and orange, the blue color shows, so light blue color shows the water body emission of reactive nitrogen. Japan shows now decline trends. It's good think about the environmental aspect. And the last slide for guidance document. So in this case, our guidance document, the intended audience is policymakers and both scientists and working on nitrogen-related environmental issues. So air quality, climate, water quality, biodiversity, and some key takeaways. One is nitrogen, national scale nitrogen budget. That is an efficient tool, monitor key pathways and intervention points of environmental nitrogen. For example, what type of policy is needed to what type of environmental media, something like that. And then, as I mentioned just before, when we got some nitrogen budget, there are effective usable data on nitrogen flow, covering all flows inside the country. So that's why then we can collect some key indicators like nitrogen use efficiency, for example, crop production, livestock production, so on. And we can also estimate the recycling rates of nitrogen. And of course, environmental nitrogen loss we can identify. And these data also enable an analysis, for example, trend analysis and benchmarking between situations, future scenarios, and so on. And the cost-effective relationships also available, for example, air pollutant emissions and its health impacts, and the critical roles or eutrophication and its ecosystem impacts, so on. I still have 2 slides. Sorry, I changed the topic a bit. So, cause I'm also taking a role as the standing committee and the director of East Asia Center of International Nitrogen Initiative. We are now planning to hold the next 10th International Nitrogen Conference in 2026, held in Kyoto, Japan, next year, 2nd to 6th November 2026. So I'd love to welcome all of you to join Kyoto, not only scientists, but also policy people, and let's have an opportunity to discuss together how we can achieve the sustainable nitrogen management for future generations. This is just for information. So now we have 12 major categories and 1 special thematic session. So I'd like to finish my presentation and once hand over to you, Bill. Thank you very much.
Thank you, Kentaro. That's excellent. Thank you so much for putting that together. And yeah, we'd love to all come to Japan next year at that conference. Let's see if we have budgets to get us there. So thank you, Kentaro. And we are having some questions coming in, but we're going to save them to the end. But do keep them coming. People are using the questions and answers box. So that's great. Keep going with those. Okay, so I'd like to move on and ask Jill Barron to come forward and start to share your presentation. So Jill is a senior research scientist at Colorado State University. She's with INMS since the beginning, I believe, and she's going to present on nitrogen impact assessment methods. So Jill, yeah, just about there.
Just about there. Okay, how is that?
That's great. Off you go. Thank you.
Okay, I am delighted to be here. I want to thank everyone for organizing this. We're very proud of our document that we're going to present today. I want to give tremendous credit to my co-lead author, Hideaki Shibata, who is from Hokkaido University, and also the 43 lead and contributing authors from 14 different countries, many of whom are listening today. We had every region of the world represented with the exception of Antarctica, and we could not have done this without a collaborative effort from everybody coming in. So this guidance document, I'd like to make this go away. This guidance document, and you can see again the front cover of ours, presents the summary of methods by which nitrogen impacts to the environment and human health are determined. It documents many ways by which the drivers of reactive nitrogen, including energy, food, and goods production, create pressures that affect states and impacts. And these impacts can be both positive and negative. Some of this you just heard in Hideaki, in Kentaro's presentation. With this background information, policy and management responses can be identified to mitigate the nitrogen impacts or enhance the nitrogen products. Excuse me. So I have bolded drivers, pressures, states, impacts, and responses for a reason, because we built the document around a framework, which is called DIPSR, drivers, pressures, states, impacts, and responses, and I'll come back to that repeatedly. You can again see our QR code to get to the document today and a URL right here as well. And I know it's being posted in the chat. We are not turning. There we go. The audience for this is threefold. We initially developed this audience, the document, to be meant for a United Nations audience. The international organizations that make up parts of the United Nations will find this document, we hope, to be useful as a reference guide. So UNEP, the UN Regional Economic Commissions, the Division for Sustainable Development, Mark mentioned all of these this morning. We also hope this document is useful for other national and decision-making bodies that are looking for descriptions of how reactive nitrogen helps or harms different elements of humans in the environment. We provide indicators and justification for those indicators that are commonly used to quantify change, some of which were mentioned by Kentaro in his presentation. We also hope this reference guide will be useful for other communities of policymakers, stakeholders with responsibility for end management locally at all levels of governance. So I want to show you that we have 5 chapters in our document. I'll run you very briefly through them. And then we have an important appendix which ties it all together in a spreadsheet form. So chapter 1 is a background. It gives you the concepts of nitrogen impacts. Just as you all are familiar with the nitrogen cascade, we talk about how nitrogen, reactive nitrogen, moves in many different forms into different parts of the environment. Chapter 2 is the summary of this framework that I've described, pressure, state, and impact functions, which has been called DIPSR. It's a framework that was developed some 20 or 30 years ago and has been applied worldwide. I'll describe a little bit of that. Chapter 3 is integrated methodologies to assess nitrogen impacts. So whereas DIPSR is a framework, these integrated methodologies are more quantitative. And some of the examples are input-output budgets. You just heard one about national scale from Kentaro. There's nitrogen footprints. Nitrogen use efficiency is often used as a method for assessing nitrogen impacts, planetary boundaries, and there's a few more. Chapter 4, which is by far the largest chapter of this entire reference document, is assessment methods by which you can look at nitrogen impacts. So it goes impact by impact, and there are many of them, and provides the literature and the justification for specific methods for quantifying the effects on greenhouse gas, human health, ecosystems, agriculture and manufactured products, and cultural services. So each one of these multiple subsections in this chapter give you the background by which how one would go about developing each of these impact assessments. And this is very useful if you need to justify why you're using one method over another. Chapter 5 gives a few examples of how these N impact related policies have been used in different countries or different situations, again, falling back on our framework of DPSR, drivers, pressures, states, impacts, and responses. And then I want to end with our appendix, which is the nitrogen matrix of impacts and pressures, which is a comprehensive spreadsheet that shows you what the impacts are on which types of sectors and how it can be used for either national budgets or economic impacts and maybe some others. So chapter 1 is the background, and nitrogen has many pathways to positive and negative impacts on society, human health, and the environment. And this document looks complicated, but it's really not. The center blue dot is all of the pathways to reactive nitrogen impacts. The white circles scattered around are all the different transformation processes that lead to different impacts of nitrogen, whether positive or negative. And the icons are all the impacts that are affected, some of which are negative. You can see a little body there that looks at human health. Some of them are related to greenhouse gases. That's a little globe there going in. Some of them are crop productivity, but it all ends up being a diagram by which you can see how nitrogen in its many forms, gaseous and particulate, can go into affecting how nitrogen is then impacting the environment, human health, or benefiting it through crop production and materials good productions. Chapter 2 talks about this framework that I've mentioned before, and you can see it in a cartoon on the right. Drivers is the green box on the left. In our case, we're looking at economy, food and energy demand. Excuse me. So drivers lead to pressures on the environment. And these are, for example, nitrogen emissions to the atmosphere, nitrogen deposition to terrestrial and freshwater systems, leaching, other types of impacts like that. Those lead to changes in states or pools if you're a modeler. And these changes in states include changes in water concentrations, air concentrations, soil quality, environmental changes. And in turn, those lead to impacts such as eutrophication of water bodies or soils, pollution, biodiversity loss. All of those are the drivers, pressures, states, and impacts that can be used to develop responses. And the responses can be done by any kind of actor. As I mentioned, they can be nations, they can be the UN, they can be smaller bodies of governing groups. And those can be how to mitigate nitrogen emissions, how to improve nitrogen use efficiencies. So that very briefly is how the DPSR framework gets used in this document. Those responses can then be used to impact both the drivers, the pressures, and the states. Those are the blue arrows going there. So all of these are how we framed our document. These responses can intervene to mitigate nitrogen impacts, enhance nitrogen products, and we use that to go through how you then determine what the impacts are. The DPSR approach applied to nitrogen looks like this. Nitrogen demand for energy, food, and goods on the left in the blue leads to pressures on air, land, water, and materials. Those states are then altered and they lead to impacts. The impacts are how we go through the rest of the document. Impacts on greenhouse gases, human health, terrestrial ecosystems, agricultural products, aquatic ecosystems, cultural services, and non-agricultural products. All of these can be used for valuation, evaluation, quantification, and then lead us down to responses at the bottom of the document here, which can then be used to mitigate either the drivers to reduce nitrogen demand, the pressures on the environment, the changes to the states. So the DPSR approach has been extremely valuable for looking at how we develop our management guidelines. The framework is developed exhaustively in Chapter 2. This is just a snapshot of a very few of the ways that we look at it. These are examples of pressure state impact pathways functions, spatial and temporal scales in effect. And if you look across the top on the green bar, you can see the category, the impact description, the pressure to state pathway, the state indicators, the impact indicators, whether it's a positive or a negative impact. And then we have functions that are developed from the literature that show how the impact changes over the different amounts of concentrations of nitrogen in the environment. And then we have spatial and temporal scales of the impact. So if I just walk you through the top one on top, aquatic ecosystems, the impact description for this specific example is marine and coastal acidification. The pathways are nitrate leaching, nitrogen deposition. The state indicators are nitrogen and pH or acidity. The impacts are going to be biodiversity, survival, calcification of, say, mussels or shellfish, growth and reproduction. There are different types of functions that describe these different changes, and it can occur at local to regional or seasonal to years types of scales. So we go through this for every one of our pressures, every one of our impacts over time in this particular chapter. In chapter 3, we go into other integrated methods. And for these, we describe input-output budgets, and you just heard an excellent example for national scale budgets that Kentaro introduced. We also go into different types of nitrogen footprint approaches, nitrogen use efficiency assessments, planetary boundary approaches, and critical loads, which have been used in a number of countries to determine how much is too much for environmental impacts. This figure on the right is just an example of 4 countries over time and how their nitrogen use efficiency has changed over time. On the top right, in the box for the Netherlands, you can actually see the years, they're color-coded. The red bars that are vertical in each and every one of these boxes describe to you the optimal nitrogen use efficiency. If you're to the left of that bar, you're looking at nitrogen mining in a country. If you're looking to the right, you're looking at excessive nitrogen inputs to it. And the sweet spot is where you want to be, which is within that red bar. So you could see different countries over time and how they've changed their nitrogen use efficiency. France, the Netherlands, Brazil, and Egypt. All of these are good indicators of how these countries are faring over time. And with introduction and in a national nitrogen budget, you could see why as it goes through. But we describe this for each and every one of our other integrated methods. Chapter 4, as I mentioned before, is our longest chapter. It goes into specific descriptions drawn from the published literature of how the positive and negative impacts of reactive nitrogen are assessed. There's a variety of methods that are used by scientists to quantify pressure-state impact relations. That's the table on the right. In environmental studies, we go through, commonly we use experiments, monitoring over time, monitoring over space. We use meta-analyses of published papers. There's modeling and remote sensing. For human health impacts, some of those are not feasible, but we do use a lot of epidemiology, longitudinal studies where we track people's responses over many years, as well as models. And for all of these methods are applied or described for greenhouse gases, human health, terrestrial and freshwater ecosystems, marine ecosystems, agricultural products, cultural services, and non-agricultural products. I'm not going into detail about any of these, but it's a reference chapter where you could go and say, I want to know about, say, the critical load for aquatic ecosystems in mountains of the world. Where would I find that methodology and the literature that supports it? It's not a manual. You couldn't actually go to this chapter and say, and find out how to set up such an experiment, but it will lead you to the literature that shows you how one could do that and how it has been used. Chapter 5, we describe 9 case study examples of impact-related policies. And we fall back again on our framework, the drivers, pressures, states, impacts, and responses to do that. The countries are listed here on the left. I'm not going to go through them all. Kenya, India, the Netherlands, New Zealand, a marine governance framework, air pollution controls using the long-range transport of air pollutants, water quality in Taiwan, 2 examples from the US Rocky Mountain National Park, and 1 from the University of Virginia. I'm going to give you a case study, two case studies, one from Kenya and one from the Convention on Long-Range Transport of Air Pollutants. And so you can see here on the left, you can see the long-range transport of air pollutions framework. It's filled out all the way because there has been work done in every one of these boxes quantitatively in order to look at how drivers, pressures, states affect impacts that then lead to responses. The example for Kenya is a work in progress. There are drivers that would demand in this case, the demand for agricultural products, but the filling out of the pressures and states and impacts is still to be done. The reason I'm going to use it is because there are responses related to the drivers, but there also have been some unanticipated impacts. So I'll describe those too, and I'm going to describe Kenya first. So nitrogen policy in Kenya, as of this writing, relates to nitrogen fertilizers to boost food production. We got this example from one of our demonstration projects for the International Nitrogen Management System, which is centered around Lake Victoria Basin. So more nitrogen fertilizer all over the country is needed to boost food production, but in some places, particularly in the Lake Victoria Basin, nitrogen fertilizer has been applied in abundance. And so the lake itself in parts is experiencing eutrophication due to unsustainable agricultural practices, too much nitrogen applied, and other types of disturbances. So if you look at the green box on the left, on the example, green box is the pressure to develop more agricultural products to increase food supply. The unanticipated impact goes down to the impact box where you're seeing eutrophication. The responses for Kenya so far have been to augment fertilizer applications, provide better fertilizer quality. They have the Animal Foodstuffs Act and targeted subsidy programs. But a fuller DIPSR approach, as more development occurs in the country, could lead to information that could help identify policy and management solutions to not only boost food supply, but also minimize the unintended consequences to the environment. An example for the Convention on Long-Range Transport of Transboundary Air Pollution was adopted by the UNECE in 1979. The Convention on Long-Range Transport of Air Pollution mitigates transboundary air pollution through cooperation and binding protocols. Yes, it uses, it was developed for Europe. It's also been employed in both in North America between Canada and the United States. It requires monitoring experiments, evaluation methods to provide about 5-year snapshots of the pressures and impacts of the drivers that affect reactive nitrogen. And it's helped states reach agreement on a number of contentious issues and achieve results, very strong results in air pollution reduction. So it's been used as a model for other international regions, including Northeast Asia. It's a very promising way of looking across countries to try to reduce nitrogen impacts while still maximizing the benefits of nitrogen. So in this case, if I walk us quickly through our example, on the left, again, the nitrogen drivers are demand for energy, food, and goods. The pressures are nitrogen emissions and deposition. The states that are altered are air, land, water, and materials. The impacts that are monitored and experiments conducted are acidification, eutrophication, ground level ozone. And the responses are the scientific identification of dose responses, critical loads, damage evaluation, and it's developed this binding international obligation for emissions reductions, which has actually created lasting and important change. I want to finish by talking about our supplemental file, the nitrogen matrix of impacts and pressures. This is a searchable spreadsheet. It's in Excel for identifying causes and effects and how it's been used, including many, many indicators. I encourage you to go to it on our website, and I'll show you the QR code again and the URL site in just a minute. But it gives you different sheets for you can look at search indicators, the pressure state impact functions and a summary, the full set of indicators, the impacts matrix full, and it goes through the mechanisms, category, pressure states, impacts, valuation, uses in models and model outputs. So, and the other thing that's very useful to it is it's a one-stop place to look for where you want to go in our guidance document if you want specific information, for instance, on pressure indicators of each impact. For that, you would go to A1.3 and you would find it there. So this is an incredibly useful tool to look through the rest of the document along with its table of contents. So just to come back to my very first slide, which is also my final slide, this guidance documents prevents the summary methods by which nitrogen impacts to the environment and human impacts are determined. It documents many ways by which nitrogen moves through the environment from the sources that we need and want that create pressures to affect states and impacts. And with this, it's a useful tool for allowing policymakers to find out how and how well justified different responses can be. So with that, I want to turn it back to Bill and thank you very much.
Thanks, Jill. That's excellent. Thank you so much for putting that together. I think there are questions coming in, so keep them coming. Some of the presenters are starting to answer them, which is good. Maybe leave some for us to answer at the end. I think I'm now going to introduce and our final presentation from Will Brownlee. He's Senior Nutrient Scientist at the UK Centre for Ecology and Hydrology. So Will, if you want to start sharing, you're going to be showing us the guidance document on measures for sustainable nitrogen management together with online database, and I'll share links to those as you're speaking, so people can have a look. Yeah, off you go. Thanks, Will.
Thanks very much, Bill. And the other speakers, thanks for inviting me to present this talk on the INMS measures database and the guidance document, which goes alongside it. Can you see my slides okay?
Yep, thanks.
Okay, so I've been part of the INMS team since before the beginning, and watched it evolve and enjoyed the advantages of being able to cooperate and collaborate with lots of scientists around the world. And one of the key, for me, findings of INMS and also the nitrogen system more generally is this need for an integrated approach. In fact, this was identified very early in the project and led to the outputs that I'm going to talk about today. And the idea is that this the nitrogen policy and management system historically has been quite fragmented between the different sectors, and that we should take advantage of exploiting synergies between this nitrogen cycle. And to do that, we needed consolidated guidance on the practices. So the reason for this and the drive for this, which is not just for the nitrogen system, but just globally on many, many resources, is this need for a transition away from a linear system of use to a circular system. And this is a figure taken from the guidance document I'm talking about today, where you can see that synthetic fertilizer still comes into that circle, but really what we're trying to get to is a point where that nitrogen resource is used around and round and round, and we don't lose it to the atmosphere where it can cause havoc. So this sort of came to three communication triptychs, I call them. And this is the guidance document in the middle, which I've been asked to talk to you about today. But this is also expanded into a database. So the guidance document tells you about some measures. The database tells you about those measures with extra information that we just couldn't physically fit in a guidance document, or it'd be too big. If you are feeling faint-hearted and you can't take on quite the amount of information in either of those documents, you can then turn to the INA chapter, which gives you a sort of 15-minute read, flash through everything you need to know. So these are the two main points that we're talking about, the guidance document and database. So they've taken 5 years to develop. I can't take full credit. There's been 42 experts that have come in from 21 countries, not including all the workshops we've had. We originally identified over 200, 300 measures. We tried to consolidate them down into a much smaller group. It went down to 70, and we found a happy medium at about 140, 150 measures. And these are identified to reduce nitrogen losses and improve nitrogen use efficiency across 7 different management stages, which we'll have a look at the moment. And what's the point of all this work? Well, it's to support policymakers, but also stakeholders in developing sustainable nitrogen management strategies. So here are our management systems. I'm sure many of you will have seen this sort of idea, how nitrogen flows around these different sectors. But we have cropping systems where fertilizer goes in, that goes to livestock systems. There's landscape management behind there. Then obviously the food and the wares go to consumers. There's organic residues, which is the sort of waste sector. We have aquatic resources, and we also have fuel combustion systems. Some of these sectors are not often talked about. Fuel combustion, certainly I hadn't seen before. I'd seen a big focus on agriculture. So these were new friends to make and new collaborations to make, which was really exciting. And equally, aquatic resource management was also something that sometimes stayed quite siloed away from things. So what does it look like? So this is a table taken from the guidance document. Identifies different measures here under different groupings. But you can see here there's coloured boxes. And there's also a reliability metric there saying robust and promising and unproven. And also there's a box covering that. There should be technological requirement there, which says high and immediate. Now, when we have a look at this key, this is sort of important. It runs through both the guidance document and the database. The colours are representative of a large reduction in nitrogen emissions if you apply this measure to a default system. So a system that hasn't been touched yet. And those are defined within the guidance document, or a medium reduction in nitrogen emissions, a small reduction in nitrogen emissions, and then you have an increase if it's 4, so maybe you shouldn't apply that, and an unclear unknown effect. That's to say it could be great, but we just don't have the data yet. The reliability it's very robust, it's been proven in science, it's promising, so it looks really good, but we just don't have the data yet to show it works across all different local circumstances. And unproven, that means it's not yet demonstrated. So maybe you need to be aware of that. If you're going to implement that measure, maybe consider doing some lab trials first. And then there's technical requirements, and they're high, intermediate, and basic, and that's fairly easy to understand. Okay, so let's have a look at the guidance document. These are some of the chapters you can see. We have, which map onto that figure I showed earlier. So we have water bodies there and landscape. We have livestock management. We have aquaculture there. It's quite visual. It's quite pretty. It has lots of information. And then it summarizes the box, which gives you all the different measures underneath different subcategories. And if you have a look there, it's very small, you can see on the right, that's actually a measure, and it gives you a rough description. So those are the measures. Importantly, throughout these, both the guidance document and the chapter, but not the database, there is this pull to encourage the users to think about integration. And that's really the thing that underpins all of these products in this guidance document. And we came up with some principles, 10 principles. This is based on 21 principles in the UN's EC nitrogen document that had come out previously. But I'll read you through these very quickly without going into them in too much detail. So number 1, integrated management should consider all nitrogen forms. I'm going to flip back through quickly because I realized I didn't make a point here. Importantly, when we talk about that principle, if you go to this table here, you'll see that these green boxes and orange and red boxes are under the different nitrogen species. So you have ammonia, N2O, NOx, nitrogen to water, N2. That's just to encourage you to think on that first principle, which I'm about to read out, that nitrogen should be dealt with across all forms, sources and emissions, temporally and spatially. The second second principle of integrated management was control of nitrogen inputs can influence nitrogen loss pathways. And this ties to number 3, any reduction in nitrogen loss must be matched by a decrease in nitrogen inputs or decreased outputs. This really is summed up with a simple figure. What goes in will come out. If you have losses and you block those losses up, well, you're going to get bigger losses somewhere else, or you're going to get greater output. The ideal situation is that you manage to block up all those leaks, and then you need less inputs and you get greater outputs. Moving swiftly on, 4, a transition to a circular nitrogen system is needed. We've identified that at the very beginning. 5, strategies aimed at jointly decreasing losses of nitrogen, phosphorus, and other nutrients like potassium are a win-win. 6, nitrogen management strategies should be developed with consideration to local physico-chemical conditions. So the regions change, agriculture changes, temperature and climate changes, of course. 7, measures must be cost effective and relevant stakeholders have sufficient resources to implement them. That changes very much across the different regions. All stakeholders share the responsibility to decrease nitrogen losses. And 9, possible trade-offs will require priorities to be set. You can't fix everything, so you have to make a best assessment what's going to be greatest benefit and what are the aims of the region. So coming back to this triptych, why have we got triptych? The database provides you more information. We've talked about this already. The guidance document, the important thing here is this provides a time-stamped overview of the nitrogen measures in the database. So this has already been published. There is a guidance document that says what's in the database, but the database itself is a living document. We can add more to that. So maybe in the next 5-10 years, we write a new guidance document, which will be a timestamp of the database once all the new inputs. And indeed, we're already engaging with new technologies and new stakeholders to keep updating them. And the INA chapter, of course, is something that is just quick and purposeful to encourage people to read the INA document and then turn to these measures if they need them. So I'm coming to the end now, but I just wanted to show you that database. So this is the database, and so what's extra? What do you get? What's the bigger bang for your buck that you get by engaging with the database and the guidance document? So just like the guidance document, you get the summary info, you get an overview of how to implement the measure, and you get a very rough idea of efficiency. Within database, these are expanded, and in addition, you get financial implications. So you have an idea of cost savings and production benefits. You get capital costs thoughts. You have operational costs. So these are qualitative, not quantitative. We have lots of conversations about this over INMS. Can we capture that in monetary terms? It's very difficult to do. Risks and co-benefits. This is a description of the key risks and the co-benefits of implementing this measure. And then importantly, we have the up-to-date references. So if you want to read more than in the database and find out where this source material comes from, you can click to that. The database also is designed to be accessible and user-friendly. It's a good user experience. I encourage you to have a look. It's very easy to navigate, and it allows us to update content very, very simply, and other people to take this not just CEH here, but other people. And you can also add other things to it. So off that, I put the next step for the database and the guidance document is, where do we go from here? Well, the database is designed to be modular, so we can build supporting sibling databases. So these might be available in the same link that you can access, or it might be somewhere else. It'll look the same, and once users get the idea of how to use the nitrogen database, then they can use it simply for phosphorus or potassium or nitrogen policies, or a focus just on recovery technologies. I should highlight that this work was a big lot of work over the 5 years, and the guys listed here made this possible. So thank you very much. And in particular, Tariq Aziz from Pakistan and Mark Sutton here from Edinburgh with me. I'm going to leave this on the screen. Have a look, have a play, see what you think, and let us know if you have some more measures that should go on the database for the next guidance document. Thanks very much.
Thanks, Will. That's excellent. And bang on time. That's great. Please have a look at the measures database. The link is in the chat, or you got the QR codes there. I'd be interested to see what reactions you have. You please, put them in the Q&A box or even in the chat. Okay, so thanks, Will. If you just like to stop sharing, we'll move on now. So we do have a session now for Q&A, and you have been putting questions into the box, and I'm going to probably start with Kentaro, pick out a couple maybe for each of the presenters. I've got one probably for Mark as well. We've got about 15-20 minutes actually, so not too bad. So Kentaro, you've already answered in the Q&A, and I'm not sure if everyone can see the answered ones. I hope so, but I think I'll ask it again, just so you can cover it around uncertainty. So Dave Chadwick has asked, has the project, this is around nitrogen budgets, has the project come up with recommendations about how uncertainties in national budgets should be calculated? So would you be able to, you've answered it well, if you could maybe just summarize your answer for the benefit of everybody? Thanks.
Yes, thank you very much. And thank you again for this very important question. So quantifying uncertainty is very important, but it's a big challenge because I explained one answer here. So because the national nitrogen budget consists of many nitrogen flow inside the nation, and each nitrogen flow may have its own uncertainty, maybe different between between flows. That is why we need to ideally quantify the uncertainty for each nitrogen flow, but it's really big task. So that is why that should be a future task. That's my current understanding. But we can, for example, refer to the relevant GHG inventories, because the GHG inventories, the greenhouse gas inventories, also cover the nitrous oxide because the potent greenhouse gas. And to calculate the N2O flows, we need to some activity data, including the ammonia flow, or NOx emissions, so on. So that is why uncertainty estimation for GHG inventories may be a good reference instead. That's my answer to this question. Thank you.
Thanks, Kentaro. And there is a further follow-up from Dave, but I'll move to Jill. So Jill, a question here. Do we have any further N impacts that have not been estimated or difficult to maybe quantify or answer today?
Yeah, I think that that's a great question. One of the things scientists are always finding is the element of surprise. Even when you think you know what's going on, there will be new impacts that show up. So one of them that we describe in the document is a research that very recently has been published. I'm going to look it up right here, where nitrogen aerosols affect through physiological processes the effects on forest health. And there was a publication on that that we cite within our guidance document. But there's so much more work to be done from the initial work of looking at the absolute physiological pathways by which different types of nitrogen are moving in to affect plant physiological processes. So it's the beginning of a research project to look at yet one more effect that had not been well studied before. Our impacts that we go through, especially in our chapter 4, are range from studies that have been from literature that's been well known and documented for many years to those that are rather novel and are coming up only now. So I think that there's quite a lot of work to be done to look at the uncertainty, to create more studies, to look at, say, the effects on above and below ground diversity, the impacts on nitrogen greenhouse gas balance. Some of those are well documented, others of those are not. An emerging body that came through our discussion was whether the dietary choices on human health actually affect the global nitrogen budget. So among the other things that we discussed and don't explicitly call out in this chapter, but I think are asking for more research, is discussion about how you mitigate nitrogen through understanding the effects of the different nitrogen pathways and how those can be most effectively managed through different pathways of looking at the effects. So to come back with a question that Kentaro just asked, and I posed myself as, how do you assess the uncertainties in each of our methods? Some of them are assessed very well in the chapter based on the literature. Some of them still need to be done, and that would be a further work that we would do following up on this to find out where we have great confidence in promoting a specific method for looking at a specific impact and then response, and those where we would still need to work more to come up with better estimates of how certain we are and at what scale those effects can be quantified.
Excellent. Thanks, Jill. I will come back to each of you, but I'll move to Will. So a question here for you, Will, if you can see it, but is there a plan to make the database searchable, interactive, to search for mitigation strategies for a specific sector? Now, I think that is there, but if you'd like to give us an idea.
Yeah, sure. Thanks, Bill. Yeah, I think there was a desire at the very beginning. I think I know what the person is asking, but if I'm not got this right, correct me. But I think there was a tendency towards the beginning of this development process to say, is there a tool that somebody from a farm could, for example, fill in, I've got 300 cows as a dairy cow, I'm based in, I don't know, north of England, Can you give me a list of different scenarios I can, use in terms of, we call it, what were we calling it? My head's gone. A toolbox of measures, but there was a better word for it. Do you remember why we were talking about this? Mark, do you remember we were doing these in the guidance document? There's a group of measures together.
Measures packages.
Measures packages, sorry. I flew back from Africa yesterday, my head's still a bit jagged. So packages and measures, yes. The idea to create measures and packages. Whether we can do that within a database is very complicated. So the stage we're at the moment is where we'd like to see the database is policymakers to come in and create their own measures packages. Because they really are the people that are suited best to know the conditions in their regions or their local systems. But if you go to the guidance document, you will see some examples of how to put together measures packages. There's 3, I think, in there. But next stage is, if we have some more funding and some more time and some more resources, that would be a great idea to be able to develop that. Especially with the advent of AI, maybe we could get something really novel there. So good question. Thank you.
Yeah, thanks for that. Mark, I've got a general question here about the current progress on mitigating N-waste. So is it still possible to halve N-waste by 2030, which is in 4 years' time, let's say? What are the barriers, perhaps across the different parts of the globe where we can achieve this, and maybe where we're not going to?
Well, exactly. I think Gisa, who's asked this question, has come straight for the jugular with, can it really be done at this distance? Only 5 years away. In principle, blink and it will be 4 years. I think, in a sense, the question you're asking is a question for another report, for the International Nitrogen Assessment, rather than for these reports, because these reports are giving us tools for getting there. Doesn't mean I'm not going to answer your question. I will, but think about that. Actually, it's going to be a washout. We're going to fail to meet those goals. Many countries fail to meet the goals to halve nitrogen waste. That means more pollution, more wasted resource, poorer economies. Therefore, in order to change the curve, we need to see countries empowered with knowledge, empowered with assessing the threats for why you would take action, as Jill has done, empowered for taking a holistic vision of all the different end pathways, as Kentaro has done in the budget guidance documents, and thinking about what are the solutions that you as a country, as stakeholders, want to embrace, as Will has just done. So here we are talking about the solutions that can turn the corner. And I think the message I would give, and I think that will come out of the assessment in due course, is that in principle, the world could change and could halve nitrogen waste by 2030. But in practice, it's not the technical issue, it's not the technical capability, it's the need for investment, building capability, upscaling. So any changes as seeded now may take 5 or 10 years to come to fruition. And that is going to be the challenge. And therefore, I think it could be a big red face to say that it hasn't been achieved by 2030, because actually we should have started 10 years ago. Of course, we as scientists have been starting 10 years ago. And I think the evidence that you're seeing presented today is, and the contribution we've done to mobilizing the UN processes is helping that. But ultimately, to really halve it will take more time. If we can see a turning of the corner already with these measures being adopted, with the knowledge base in countries already coming into fruition by 2030, that we're on a different trajectory, then that will be a form of success. But let's say that's for the countries who've signed, for example, the Kunming-Montreal Global Biodiversity Framework. Is still for you guys, if you are out there and you're representing a country and your country has signed up to that, we would love to see it and help you to make the changes that are needed. But we do recognize that investment in change takes time.
Thanks, Mark. Yes. I'm going to, a few more questions coming in. I'm going to go to Jill actually around data. There's a question about how the case you gave of Kenya was really interesting, and this person is from Benin, and they need help from monitoring and data. And I think I'll also bring in Kentaro about this. A similar question about how can global South countries, countries with little in situ measurements, get round this problem? You know, what analysis or more data could be made available? So Jill, do you want to tackle that, the problem of data poverty, maybe we could call it?
Yeah, and I want to thank whoever asked this question. To me, it's the perfect question. If we're getting people who haven't been involved very much in this effort of nitrogen management interested in asking how they can take advantage of what we put together, I think we've succeeded with our documents and with the forthcoming international nitrogen assessment. Any of us would love to come to Benin and work with you to find out, as Mark just mentioned, what are your priorities? How do you want to manage nitrogen? Is it to improve crop yields? Is it also to minimize environmental impacts? And from that, we could develop collaboratively with decision makers and scientists in country ways by which you could start to measure and monitor those changes so that you could work toward a more circular, as Will was talking about, nitrogen economy. So it's the perfect question, and I want to thank you for asking it because it sets us up for what we want to do going forward.
Yeah, and similar question was given around the budgets. Kentaro, similar thoughts? How do you overcome
Yes.
data?
So maybe we need to take a step-by-step manner. So cause the covering all nitrogen budget in a nation is a very big task. So that is why I recommend to focus on the very most important flow in your country, like crop production or livestock production, so on, or environmental reactive nitrogen loss, for example, atmospheric emissions or effluent emissions, so on. And in this case, some global database can support some relevant data. For example, crop production, livestock production, FAO has a great database, FAOstat, that may help you. And the IFA also provides some data regarding the chemical fertilizer production and consumption in the country. So for example, making a base of your activity, focusing on a narrow range of sector in your country, and then you can expand the coverage of the nitrogen flow, including some other sectors, or expand your estimation for time scale, like first calculate on very recent years and expand to the past years, 5 years ago or 10 years ago, so on. Such a step-by-step manner would be good. I recommend this. Thank you.
Yeah, step by step. So that's good advice. Will, come to you now. This is a really good question about the measures database. So have you taken into account regional climatic conditions, you know, in terms of what's representative for countries to use which measure? You know, could there be a filter for regions perhaps? Is that an idea?
Yeah, so originally there's been about 3 or 4 different versions of these databases, and there was a balance between keeping things simple so people can interact with it easily, and then trying to find a way of providing every single possible option with it, and then people maybe not engage with it. In the end, we didn't provide a bi-regional filter. We provided sectors you can search by, but if you go into the actual information in there, whenever there was anything that was specific for region, we added that into the overview. So you'll find that information in there. The same for the guidance document. But of course, this is an opening call to the global community that if they wish to have a database specific for their region, get in contact, because we can start filtering that and building that for you. But at the moment, no, that's not a searchable criteria within the database.
Thank you. Thanks. Yeah. So to come, let's see. I'm going to go back a bit to the uncertainty. I'm going to give this one back to Mark. Actually, we might have time for one more after this. So without some form of uncertainty quantification, we will oversimplify messages about the really complex inflows and processes, and these could possibly misdirect policy response with quite uncertain underpinning information. So perhaps the project outputs recommending national budgets should be accompanied by clear statements where there may be limitations in data quality and data confidence. So it's policymakers liking a single number, but they need to know levels of uncertainty. Mark, would you like to tackle that one?
Yeah, very happy to. And I think the point here is to be pragmatic. The challenge with uncertainty analysis is that you can suddenly find out that you've just made another project or actually 3 projects, because to do uncertainty analysis well can make triple your effort. And I think, therefore, we have to be realistic about that. And I think, as the question is indicated, I think from Dave Chadwick, an indication of uncertainty is often what is needed. So sometimes the question would be, what are the uncertainty limits of my uncertainty limits? Because actually it's quite challenging to estimate that. So I think an indication of uncertainty can often be sufficient. The second thing is to say is we should be very clear about what we want to get out of nitrogen budgets, and that will have different people having different purposes. So for me, I will often say that the budget is a representation of nitrogen that could be wasted or could be used, and therefore I want to know the total value, because I'll multiply those kilograms of nitrogen by dollar values and get a wasted amount of resource. What that means is that if it's a very small number, if it's rather uncertain, it doesn't make much difference, because 1 kilogram plus or minus 3 is still a small number. But if it's 1 billion kilograms, I really want to know the uncertainty limit. So that pushes towards prioritizing a good estimate of uncertainties on the big absolute numbers, because that's where the opportunity is for recovering economically valuable nitrogen. And so to give an illustration, ammonia emissions are uncertain, and dinitrogen emissions are uncertain, and so are nitrous oxide emissions. But the nitrous oxide emissions as a nitrogen resource are a very small number, whereas the dinitrogen emissions are both uncertain and a really big number. And therefore, there's a very clear policy message there that not only is denitrification a big waste of nitrogen resources, but also it's an extremely uncertain one, and putting efforts into better quantification of that will give us a better handle on the overall availability of resource.
Thank you. Thank you. Okay, I think that's great. I think each of you've had about 2 questions there. Do keep trying to answer, but I think we need to wrap up now. I've put the URL to the reports page on INMS, where you can find these guidance documents and other outputs. I would also just announce that we are releasing 4 more guidance documents to come. So very quickly, there's one on end budgets for dairy farms, very important one. We're doing a guidance document on nitrogen use efficiency indicators across multiple sectors. That's coming out, multiple scales. That's coming next year. There's a guidance document on measuring fluxes and distribution methods. So that's a good one. And then there's one document on linking driver and pressure nitrogen indicators. So we've got 4 more to come. We'll be publishing those as they come out, and maybe we're having another session to look at those. But I think we've come to the end. I do thank you. With a few minutes left, I'm going to hand to Ning Liao, who is with UNEP and also on the GPNM, who will say some final words and close the session. So Ning, over to you. And thanks everyone for coming, and our presenters.
Okay, thank you very much, Bill. Ladies and gentlemen, as we conclude today's webinar, I would like to extend my sincere thanks to all of you for your active participation and thoughtful engagement. We were honored to launch several new guidance documents and tools for sustainable nitrogen management through this webinar. These resources are more than just publications. They are practical instruments for action. They provide tools and methodologies to help governments, institutions, and stakeholders integrate sustainable nitrogen management into national policies and international commitment. They also promote best practices, support informed decision-making, and foster collaboration across science, policy, civil society, and industry. On behalf of the GPNM Secretariat, I would like to extend our sincere appreciation to our distinguished speakers, Professor Kentaro Hirashi, Dr. Jill Barron, and Dr. Will Brownlee for their insightful presentations. We are also deeply grateful to Professor Mark Sutton for his leadership in guiding this important work. Special thanks go to Bill Billy for moderating this webinar, and to my colleagues Isabella and Vanjiro for their great efforts in preparing this webinar. Looking ahead, the 7th sessions of the United Nations Environment Assembly, UNEA 7, will take place in Nairobi, Kenya from 8th to 15 December 2025. Tackling nutrients pollution remains a key priority for the United Nations Environment Programme, and we are committed to working closely with all of you to advance sustainable nutrients management for the benefit of people and the planet. Thank you once again for joining us today. We look forward to continuing this important journey together. Thank you very much. Now we close this webinar. Thank you. Bye-bye.
Thank you.
Thank you.
Thank you very much.
Bye, everyone.
Thank you.